This is the pre-lab video for gas chromatography. Chromatography is the separation of mixtures. We have lots of different types of chromatography, but gas chromatography is separating gases. So this is a very simple picture of the schematics of a gas chromatograph. We have a carrier gas, that's called a mobile phase, mobile meaning moving. So we have one part that's moving and one part that's stationary. So we have a mobile phase and a stationary phase, which is quite often what we have for all of our types of chromatography. In this lab, our carrier gas is just compressed air. And compressed air is forced through something called a column. And the column is filled with our stationary phase. It doesn't move, but the sample, which is injected in this sample port and moved along with the carrier gas, is passed through that stationary phase, depending on its properties like boiling point and size, so molecular mass, its polarity. All of these things will dictate how it interacts with that stationary phase and how long it will stay. So it can be attracted to the stationary phase or not, and there's different degrees of attraction for different compounds. So different compounds will be retained or stay on the column longer. So it's passed through this column and mixtures are separated. Once it's through the column, it comes through a detector, and the detector will produce something called a chromatogram. And the chromatogram has a baseline when the detector does not see anything, doesn't detect any solvents coming off, and then it will give a peak when it does. And the peak, the time that it takes the peak to come off is called a retention time, and the size of the peak depends on how much the detector is detecting. So we can use gas chromatography for qualitative purposes, meaning what is it, and quantitative, how much. We're just going to do a qualitative lab this week. This is a picture of our unit, and you can see the student here is injecting a sample into the sample port, which is right here. So what you can't see in this picture is the oven, right? So we're going to be changing the temperature of our liquids. We're going to be injecting liquids into the GC. The temperature will be higher than room temperature. We'll volatilize the liquid, turn it into a gas. The gas will pass through the column, and the detector that's also contained within here, which you can't see, will detect the components. First, you'll be injecting known samples, so known solvents, alcohols and ketones. When you inject just a single solvent, you will get just one peak. So if you're injecting acetone, for example, you will see something like this. The peak comes off always at the same time. So the time 0 is when you inject the sample. And then this time, which is, I guess this looks like about 1.5 minutes, the peak, okay, so the maximum spot is about 1.5 minutes. That's called a retention time. Acetone, given the conditions that this was injected under, will always be eluted or come off the column at the same time, and that's called a retention time. So now this can be used for identifying purposes. When you have known samples, you will have one peak, and you will identify what the retention time is of each of your knowns, your known alcohols and your known ketones. This is a picture of what you will see on your display. So this is obviously a mixture of 3 components. There are 3 different retention times for each of these peaks. So in this case, there's a peak that's 2 hexanone, and this 4.82 is the retention time. And again, the retention time is an identifying characteristic. So the purpose of the lab is to identify what your unknown contains. You will be comparing the retention times of the peaks in your unknowns, okay, so you'll have 2 or 3 components within your unknown, to the retention times of your known solvents and identify them. So in your conclusion, make sure you put in the identity of what you believe is in your unknown samples. The needles are very fragile. These syringes that we use for the GC are made to deliver very, very, very small volumes, and they're really easy to break. You can bend the needles, you can pull the plunger out, you can break the glass syringe. So we have to be extremely careful with these. Do not force the needle into either the vial that contains your samples or the sample port. If you feel resistance, just rotate the needle slightly until it goes in easily. You will support the bottom of the needle when you insert the needle into the sample port. And let me show you the picture of that. Right here, there's the student holding and supporting the needle while they inject. Do not pull the plunger all the way back. The most it should be pulled back is halfway. That will prevent it from being pulled out the end. So this is a really neat lab. I hope you enjoy it, and this concludes this video.